This time, we are going to show the standard matrix for a composition of a linear transformation. We did standard matrix for linear transformations in the previous videos. Here, we are going to show the standard matrix for a composition. We have here these two forms here. This is the first composition. We are denoted by linear transformation T being the composition of T sub 2 and then T sub 1. And the other one, T prime rather, would be the interchanging of T sub 1 and T sub 2. And it's not necessarily, or the results are not necessarily the same. Hence, we need to really properly multiply them. Okay? And then this could be, if you would like to know deeper on this, but of course, this is not the concern of this video. Let me just rewrite this manner. This composition is, of course, equal to your algebraic composition in your functions. So it's just like that. The T prime could be T sub 1 and then T sub 2 V. Just like in your functions, a composition of functions, there's not necessarily commutativity for composition. Well, either way, to show the standard matrix for the first composition represented by T, this is actually with matrix A. And that matrix A is just a product of A sub 2 and A sub 1 matrices. This would mean that the linear transformation, or the standard matrix for the the standard matrix for the composition of a linear transformation T prime is also A prime, which is just a product of A sub 1 and A sub 2. Just like in matrices, there's not necessarily commutativity in multiplication. But where do we get this A sub 1 and A sub 2 matrices? Our A sub 1 matrix is taken from this linear transformation here. Okay, so take note that our codomain is R3. So this is our A sub 1 is a 3 by 3 matrix. And since we have x, y, and z, we take out the coefficients of x on our first column, y second column, and z for our third column, depending on the entries here. So the first entry, we only have x. So that's actually 1, x. We don't have y. We don't have z. Just like that. Next is y. We don't have x. We have 1y. We don't have z. And for the third entry, z. So we don't have x. We don't have y. We just have z. That's actually the matrix representation of this linear transformation here. Our A sub 2 will also have the same process, but it's easier. Because if you're going to look at this, x, y, z still, but our first entry is 0. So there's no x, there's no y, there's no z. So that's 0, 0, 0. Our second entry is x. So that's 1x. We don't have y, we don't have z. And of course, our third entry is also 0, 0, 0, 0. Okay. So this is the form of our A sub 1 and A sub 2 matrices. And we are going to show the results of these two following the product as they represents the standard matrix for a composition of specific linear transformation. So to do that, we are going to use here A. For A, which is the standard matrix for the composition T, is a product of A sub 2. We have 0, 0, 0, 1, 0, 0, 0, 0, 0. Times A sub 1, which is 1, 0, 0, 0, 1, 0, 0, 0, and then 1. So again, it's easier to look at because we have a lot of zeros. When you multiply that, you simply follow the process of multiplying matrices. But of course, this is a 3 by 3 matrix. This is also a 3 by 3 matrix, so our product is defined. The first product, all of these entries are zeros. When you multiply that, that's automatically 0. When you multiply the second column, 0 as well. And the third column, 0 as well. When you multiply your second row, 1 times 1 is 1. 0, 0, so you have 1. Next, 1 times 0 is 0. 0 times 1 is 0. That's also 0. 1 times 0 is 0. 0 times 0 is 0. 0 times 1 is also 0. And since our third row, just like our first row, are all zeros, we're expecting here 0, 0, 0. If you would like to, you might want to check 0 times 1, that's 0, 0, 0, 0, 0, 0, 0, 0, and 0 as well. In short, the standard matrix for the composition of the linear transformation denoted by T is this matrix here. Duplicating the same process for our second, you will have A prime, the product of A sub 1, which is 1, 0, 0, 0, 1, 0, 0, 0, 1, with the A sub 2 here. Okay, let's find out what is the result of this when you multiply them. Again, they are both 3 by 3 matrices. Let's start. 1 times 0 is 0, 0, 0. This is 0 times all zeros, so that's 0. 0 times all zeros, 0 as well. 0 times 0 is 0. 1 times 1 is 1. 0 and 0 is 0, so that's 1 as well here. Okay, so this row multiplied to all zeros, so 0 as well as the third column of zeros. This 0 times 0, 0 times 1, 1 times 0, 0. 0 times 0, 0 times 0, 1 times 0, 0. 0 times 0, 0 times 0, all 0 as well. So we see here that the standard matrix for the composition of a linear transformation denoted by T prime, here A prime is also this matrix here. Now we see both results be equal to equal matrices, but it doesn't necessarily mean that they are equal all of the time. Okay, so the next videos you could see that it may not be no longer equal to each other. So again, just like what do you call this one, multiplication matrices, some forms maybe look like commutative, but not all the time it's commutative. So just like this, in our composition, doesn't necessarily be commutative all the time. So please check the next video for this and the last one, as we're going to talk still with the standard matrix for a composition of a linear transformation. Thank you very much for watching.